Hi, welcome back. We're going to continue with our discussion on solving quadratics. We're going to move into using the quadratic formula. Our previous lesson, we were using the square root property, which gave us techniques to take the square root of both sides. If I could isolate my squared term, and we had to remember to put the plus or minus in front of it because our original number could have been positive or negative before we squared it. And we're going to build on that. We're going to have a lot of square root work today. So we're going to discuss what is the quadratic formula. We're going to look at some key components of it, particularly what is the discriminant and how do I use it to interpret the number of solutions and the types of solutions. And then finally, we're going to use our calculation of the discriminant and use it along with the other components of the quadratic formula to solve using the quadratic formula. So let's get started. Okay, the quadratic formula. It took many minds to actually come up with this, and mathematicians had been cultivating the groundwork for this for hundreds and thousands of years. But René Descartes is the individual, the mathematician credited with developing the modern day version of the quadratic formula. And basically what he did was he took that standard form of a quadratic, ax squared plus bx plus c equals 0, and he completed the square using that, no number coefficients but just letter coefficients, and he came up with what is now called the quadratic formula. X equals the opposite of b, or negative b, plus or minus b squared minus 4ac all over 2a. Now I wonder, do you recognize this component right here, negative b over 2a? Well, that's how we found the x-coordinate of our vertex, right? That's the axis of symmetry. So our two solutions are going to be to the right of the axis of symmetry and to the left of the axis of symmetry by this amount, okay? So in order to use this, we're going to put our equation in standard form, which means we're going to get 0 on one side of the equal sign. We're going to correctly identify A, B, and C, because if you can, as you can see, if you don't get A, B, and C right, you're going to make some poor calculations. So you want to get A, B, and C right. That's why I've been pushing this the whole time. We're going to write our formula every time because it helps us remember. It makes it develops a memory muscle, all right? So don't not write the equation. In other words, do write the equation every time, all right? We're going to plug in, and it might feel a little bit different because we're going to calculate one component of it first. We're actually going to calculate the component b squared minus 4ac. We're going to do that first before we calculate the full value of our solutions. That b squared minus 4ac, it is an integral part of the formula. It's the piece underneath the radical, but notice that when we calculate this number, we're not taking the square root of it. We're just finding its full value, b squared minus 4ac, all right? That one value will tell us the number and the types of roots that we're going to get for our particular equation. So when the value of the discriminant is positive, there's two things that can happen. It can be positive and a perfect square, positive and perfect. If that's the case, you're going to get two rational solutions. You could still have fractions, but they're simplifiable. You're going to get rid of any square root symbol, all right? If it's positive and not perfect, that's when you get two irrationals, because remember we learned back in September and August that the square root of a non-perfect number is an irrational solution. They're still real, but they're irrational. We could also have b squared minus 4ac equaling 0. and that means the number of the under the radical is 0, and so we just get one solution. This is when the graph touches the x-axis and then bounces back back to the same direction. And then b squared minus 4ac is less than 0. That's when we get the complex solutions. This means that the graph does not touch the x-axis. Misses the x-axis. This one says it touches x-axis. And remember, this is that our value b squared minus 4ac less than 0. That means it's negative. All right? So we can have several scenarios. It can be a positive number, it can be equal to 0, and it can be a negative number. If it's positive and perfect, it's rational. If it's positive and not perfect, it's irrational. If it's equal to 0, then it's one rational solution, and if it's less than 0, it's two complex solutions. Complex numbers always come in pairs. So we're going to find the discriminant. We're going to describe the number and types of roots, and then we're going to find the exact solutions. This means no decimal. No decimal. We're going to simplify our radicals. All right, and then we're going to use the quadratic formula to do it. So always check for standard form. Is 0 by itself? Yep. Then we're going to identify A, B, and C. So A is 1, B is -6, C is 2. And then we're going to plug in and we're going to calculate this number first. B squared. So -6 squared is 36 minus 4 times 1 times 2. So this is 8. So 36 minus 8 is equal to 28. This is positive, but it's not perfect. Not a perfect square. So this is going to be 2 irrational solutions. Okay? Now we're going to use this formula, but notice that we've already calculated this number. So instead of recalculating it, we're going to plug that back in. We've already done part of our work here, all right? So we're going to go x equals the opposite of -6, so that's +6 plus or minus the square root of 28 all over 2 times 1, which is 2. Don't forget that. A lot of students will forget to actually multiply by a, because so often it's a 1. I'm going to go over here and just find the square root of 28 by prime factorization. That's 2 and 14 and 2 and 7. So I'm going to take out a pair of 2's as a single, and then under the radical stays the 7. So this becomes x equals 6 plus or minus 2 root 7 over 2. Now I'm going to simplify even further, and I'm going to split it up. You don't have to, but hopefully you can see what's going on here. 6 over 2 plus or minus 2 root 7 over 2. And I'm going to cancel, so I get 3. This becomes 3, and this becomes 1. So 3 plus or minus root 7, and I'm going to write them as ordered pairs. 3 plus root 7, comma 0, and 3 minus root 7, comma 0. Let's try the next one. Check for standard form. All right, so go ahead and answer the video question and write this in standard form. Okay, so x squared minus 4x plus 13 equals 0. Now we're going to identify A, B, and C. A is 1, B is -4, and C is 13. Now I'm going to calculate b squared minus 4ac. -4 squared is 16 minus 4 times 1 times 13. When you plug that into your calculator or you do that math in your head, you get negative 36. This is a negative number. This means I'm going to get two complex solutions. They're imaginary, so they're not x-intercepts. So we're not going to write them as ordered pairs, okay? So make a little note, no ordered pairs, because it doesn't touch the x-axis, it misses it. Now I've already calculated this b squared minus 4ac, so there's no need to do it again. So, excuse me, x equals the opposite of negative 4, so that's positive 4 plus or minus the square root of negative 36 all over 2 times 1, which is 2. Okay, I'm going to simplify my radical, and that gives me x equals 4 plus or minus 6i. The negative comes out as an I. We learned that in our complex number discussion. And the square root of 36 is 6 all over 2. And now I'm going to rewrite it. Four over 2 plus 6i over 2, which gives me 2 plus or minus 3i. So my solutions are 2 plus 3i and 2 minus 3i. And I don't write them as ordered pairs. Sorry, my pen keeps doing it. Okay, 2 plus 3i and 2 minus 3i, not as ordered pairs. All right, we're going to keep going. We're going to find the discriminant. We're going to describe the number and types of roots, find the exact solutions using the quadratic formula. Am I in standard form? Check. Go ahead and find a, b, c, and calculate b squared minus 4ac and answer the video questions. All right, so we should have had 1, negative 11, and 10. And our b squared minus 4ac is 121 minus 4 times 1 times 10. So that gives me 81. It's positive and it's perfect. So that means I'm going to get 2 rational roots. And these are going to be ordered pairs because they're not imaginary. I'm going to find the exact solutions. I'm going to use the fact that I've already calculated b squared minus 4ac, which is positive 81. So I get x equals 11 plus or minus the square root of 81 over 2. All right, the square root of 81 is 9, so I get x equals 11 plus or minus 9 over 2. So when you calculate this, it becomes x equals 11 plus 9 over 2. Remember, add those together before you divide. So that's 20 over 2, which is the 0.10. Then we're going to find x equals 11 minus 9 over 2. And that's going to give me 2 over 2, or the 0.1, 0. All right? And look, 2 rational roots. These are both very pretty rational roots. All right, this is our last example. We're going to find the discriminant, describe the number and types of roots, find the exact solutions. That means no decimals. Here we go. I want you guys to actually complete this whole thing and then come back and check. All right? All right, here we go. We are in standard form. Our A, B, and C is 1, 6, and 9. Our discriminant is 36 minus 4 times 1 times 9. That's going to be 36 minus 36, so that's 0, which is going to give me 1 rational root, which means I'm going to have 1 ordered pair. I've already found b squared minus 4ac, and that's 0, so I get x is equal to negative b, which is negative 6, plus or minus the square root of 0 over 2. The square root of 0 is just 0, so we get x is equal to negative 6 over 2, which is negative 3, 0. Now be careful, because most of our examples, a was 1, but this can very much be a number that's not 1. And here will be our assignment. Thanks for listening, and I will see you tomorrow.